Before that, chapter 5, last part. Okay, chapter 5. Anyone do know the dependency diagrams? The dependency diagrams. Anyone do know? Okay, join the tables, all the partial quantity in the first normal form. That one. Okay. If midterm test come out that kind of question, okay, can answer? Cannot. Why? Luckily, I didn't plan this earlier. If not, they are heading. Okay? Normalization. Okay? And we'll go to last part of chapter 5. Okay, last part, before we go to any chapters. Okay, so the last part of it, chapter 5 is denormalizations. Okay, we heard about denormalize means I reverse. Okay, reverse the normalization process. Okay, we only focus on third to second. Our denormalization only happen from third normal form to second normal form. No others. So tell me, oh, second to one. No need to do no normalizations at the end. It's only on third to second. The reason behind it is they want to reduce a joint. Okay, so when you reduce a joint, one joint, then you can run faster. This is why I asked you to put the subtotal, selling price, all these are in the same tables. Because on the table itself, you can get the answer. You don't need to link to other tables to get the result. For example, the order total of the order. In the order table, got one total amount. From the table, you can get already. You don't need to go for the link to the order detail, this one type this one to get. And after that, plus, get the total. No need. On the column, you can get already. That's why more faster. If you want to see the total for each order, write one statement. So like especially when order number equal this, from the order table, you can get already. That's why trigger very important. Trigger. So that's why you will reduce the joints. So you can imagine if you really want to write a query to get the total amount for the order, what you need to do? You need to link to the order detail to get the quantity and price, then get the subtotal or add out the subtotal, then in the end you can get the grand total. So they want a lot of process. In order to minimize all these things, I put the total amount in the order table using trigger. So when I write a query, I should go to order, this order, what amount? So you don't need join. Okay? So most of the time, normalization also goes, we can do something on that. So I'll give you two samples. When you go to the last two pages, the normalizations. This is what I want a bit, I tell you. Your postcode and city. Okay, your postcode and city. For example, 53300 Kuala Lumpur. But you will never see a lot, any people break this one as a single table. Post table, postcode, state, or this no state, area. Nobody write this one new table. Just post table with two columns. Postcode, area. Nobody do like that one. All they put in the same tables. Actually, that one we can consider as a third normal form change back to second normal form. Okay, so like this case. Okay, so your address never break the two table one. All remain the same in the single tables. Okay, if you want to break, also put in single. Postcode 60 all in the same tables. Okay, how to do the control? We can write also the check condition. Okay, you can write the check condition. I refer to certain library to list out all the postcode. Okay, so this is regarding your address. Of course, they will give you some duplication, especially the area name. Okay, so this is one of it. The second one, practical example, is using for the next case. Is this? This is regarding the many-to-many relationship. Okay, vendor, item, price, code. This one like what I suggest to you, purchase order, similar. Because you cannot base on one supplier, your items or your ingredient. You have few suppliers to supply the things for you, because then you can compare the price. If I give you cheaper, better one, better offer, then you order from them. Okay, don't stick on any one supplier for real business work. If not, they don't want to provide an ingredient to you, then you cannot do your business already. Am I right? So remember that. So that's why I can see here. This is a third normal form, 3 tables. Item distribution. You can see this one only 1, 2 columns. That's why a lot of cases when I see your ERD, I told you, hey, why only 1 table got code and name only? Like for example, a student tell me, certain category, food category. So got main course, dessert and so on. Then what for you want to create a new table? No need lah, just put 1 column name as a category inside your menu. The menu, then you can choose. You can type the code, check this category in main course, dessert, beverage and so on. Just single column. No need break a new table like this case. Okay, this case is doing what? Item description. They join back to the item code. So now become 2 tables, vendor and the item code instead of 3 tables. So this is called denormalization. From third, go back to second. Because you see not only 1 code, 1 column only. No point. So that's why a lot of people, I take out the category table, and one of it is I don't forget status or something like that. So no need all those tables. Just put back. For example, cancellation, order cancellation. Some people put 1 more new table, order cancellation. No need. In the order table, then you just put status, pending, cancel, or complete. No need new table. Okay, so this is called denormalization in practical work. Okay, so as I mentioned last week, last time in the data select segment, I teach you multiple table select, right? This table, comma, order O, comma, order detail OD, something like that, right? This is old format, okay? But you still can use it. But in real world, most of the time now they're using the join on, okay? Join on operator is better for join. Means they only find the matching one only. They compare only the matching pair. But for the normal old methods, the times table and just choose. So that's why you have a table larger, then you need more time to search. Okay, therefore, in practical world, they use join on operator most of the time now. Because this join on introduced on 1992. Okay, so and where statement that one is 1985. So just a few years back. Okay, so this is what I searched information for ChatGPT. Okay, tell me like this. Yeah. So now we finish at chapter 5 already. Anyone want to ask regarding chapter 5? Very important, 20 marks in your midterm. 20. 20. Okay, 20 marks in your midterms. Another 30 from ERD. No, not ERD. ERD got focus on ERD. ERD and theory about chapter 1, 2. Chapter 3 ERD lah. It's also theory question also. It's regarding ERD. Then after that, chapter 4. Chapter 4 also a lot of marks. The algebra one, the symbol one. Just draw some symbol can get some marks. I think you will feel happy lah. Okay, some people like drawing one. Final exam draw cartoon, now you draw symbol lah. Okay. Yeah, these 2 chapter 4 and 5 very important. Many marks. Then chapter 1 to 3 only theory. Few marks. Okay. So now we continue with chapter 6. Okay, chapter 6 got many things. So I play the video for you lah. Okay, like bitmap join index. Okay. Never mind, I play chapter 6 one first. Okay, chapter 6 Chapter 6 they got regarding the index. So they'll tell you what is the index, signature, subspace, area, and tree. Okay, I'll play this one later. I'll go to the lecture notes first. Only 20 slides, so it's very fast. After that, you can play. Okay, so go to chapter 6. Okay. Chapter 6 coming up in the past year. Okay, and the past year questions. Okay, focus on the rules. Okay, the 9 rules plus how to apply these 9 rules. 9 rules and application of these 9 rules. How to do? Okay, all this inside the notes. Okay, now go to one by one. So remember, Oracle automatically create primary index for every table when you fix the primary key there. Remember, so primary key is a component to come up with the index. Okay, I hope that you know why we need index file. You have an index file, then you can search the data more faster. Just like you're in the library system. Last time you got cut right, wow, all the books start by A, all the books start by B, and so on. From starting. The other day people have, hey, how about I computerize this? So A on which cell and so on. Same thing at here, our index. Maybe they pick the first record for every page. Let's say one page got 100 record. So every first record they put the index. Okay, this one A or refer page 1, C or page 3. Directly, you don't need to refer to page 1 and 2 again. C start from the page 3. So the index will put C point to page 3. So that's why the index can cut short the searching time. You don't search from starting until the end, one by one. You can jump. Okay, so this is the reason why I have the index. But we need to limit number of index in a single table. Maximum 3 to 4. Do more than that. Okay? Because we can create many index, secondary index, primary index, and so on. So if can, do more than 3. It's possible. Okay, why? Because this will increase the overhead of the insertion and deletion. Because when you delete record, your index may affected. So you may remove certain index or whatever will affected. Okay? Therefore, they do multiple jobs. So after the data you delete, you also modify the index file. So you have more index in a single file. Their overhead on insert and delete. Update not very affected because update just point to change. The index file not affected. Okay? So this is the reason. So now we run this. Okay? Create index with SQL. So we go write create queries segments. I hope that in your assignment you can create one index. Every student go to create one index and tell me why you need to create this index. Okay. So of course other than primary index. Your primary index is automatically created by Oracle anymore. You create other index. Such as what? Such as your this name of the menu. Menu name. Like Shopee. When you can see Shopee, they create index by what? By name of the products. So now it's time we search by name of the product. You searching also search by product name. Am I right? So that's why they index that columns. Because a lot of people search by name. Therefore you can create index. So this is also considered as a frequency. If many people you ask the same question, then that column you do indexing. Okay, so there's a frequency also affected which column is generate index. Of course, I've got certain other keywords. Okay, later we compare. So after that, you can compare performance in retrieving information when indexes are used as when they are not used. Okay, so explain the role of inverted index in the located document in the collection. This inverted index is using by searching and search engine like Google search. Okay, search engine. Those file access very frequent one, we put at the top. I mean, a lot of people access the same website, then you put at the top. So, but this one can do some background job. You hire people, hey, tell me to top up this page, become the higher ranking. They got this kind of job. Okay, access. Oh, now many people access this sign, they put at the top. When you want to buy, people want to buy something, your link is in the first one. Or you guys $1 买. But you know computerized, like they got people do all this kind of job. Okay, they help you to hit this access for the same link. So they'll think that a lot of people want to buy things. First choice is this. Okay, all this you can job This one also is one of the part-time job for you, but if you know how to do that. Okay, so this is thing. Then after that, this index. Okay, a special lookup table data structures that search engine can use to speed up the data retrieval. So for example, here is like book index, okay, and book category in library. Okay, so this is a search index. Okay, so this the idea for index is actually from the library system. Because last time, old time ago, don't have the computerized system. They use card one. Book start by A, B, C, they find the card. Long time ago the old one, old system. Okay, the other day they computerized it. So this is a syntax of the create index. So create index or create unique index. Okay, create unique index on table Coder name and so on. So when you're going to create index and when you create unique index, primary key is automatic unit anyway. Am I right? Anyone primary key can duplicate one? Then you just create index. Just create index. But those column, okay, is unique, okay, but it's not primary key. For example, IC number, email. Some website they're using this tool to verify what, whether send email to apply twice, something like that. Then these two columns, name, email, okay, can index, can create index. Okay, unique, for example, IC number, sorry, create unique index, IC number, for example. So when they see the same, how come the same IC number? Same login, deny. I mean this already login. Okay, actually our college, your attendant also can do one, no? But I tell them many times they don't want to do. Verify the ID, phone ID. As long as I get the same ID login second time, can catch on. I tell them many times already, very simple. I'm database lecturer, I know each one very simple, you can do one. But they do one, that's why I manually tell you, cannot log in more than one device. Actually can do one, just do this index. Then they see, why this person want to access denied, at least now your login is being used just now. Can do one, but they don't believe me, they just because maybe they're so busy, so busy. Busy, you know CITC always busy one. Okay, so this is answer. Create index, what index name, then on which table, which column. Okay, after that, draw indexes like that. So the syntax is very simple. So I want you to create one index. Other than primary index, other than primary index in your assignment, 2 marks. No, here 2 marks, there 2 marks, here 10 marks. You know, so this is one of it. Index. So this is the 9 rules, very important. There is a 1 partial question. Ask the student list out the any 5 rules. Okay, but also got question is how to apply these 9 rules in the select statement given to you. Which column you need to pick for index now. Okay, I just tell you very simple. Your primary key can be indexed. Your foreign key can be indexed. Anything in group by, okay, everything in group by, everything in the order by. You also can use it to become index field. Okay, later I go to one by one. This one mentioned order by and group by. Okay, use on the large tables. If your table only 10 record like our this branch, 6 only not many, correct? So primary index enough lah, the primary key. The rest of index no you do anything because it's very less. Okay, unless got few thousand or few thousand branch and so on, then you need to do additional. If not, no, just one. Okay, so large table using more suitable. Okay, smaller size of table no need. Okay, index and the primary key for each table. This one automatic for do by Oracle, automatic. Okay, primary key. Then after that, everything frequent search in the where clause. Okay, just I want to tell you where name like what search by name that's why lah. We create index for name for that name. A lot of people search name like what. Okay, you don't need to type the full word, right? Full detail of the description, right? It's just one word only. Sometimes one word. Okay, forget they all this out of okay. Okay, so something like that. Where? So you can see. Remember where group by having order by group by all the thing item inside there can be indexed. So this is a rule to remember. Okay, if can more than 100 value. Okay, more or less than okay, 6. Avoid of indexes for field with long value. For example, your address field is not suitable for create index because your address too long already. Sometimes 4 row, not 4 row lah. They 1 row but very long, not suitable. Okay, name okay, product name okay. Okay, product descriptions also not very good lah because very long. Product description you see when you go to Shopee, when you click at the bottom, something like import from where, it's too long. So name more suitable than description. Okay, so this is what I did here. Avoid the long value columns. Then if the key to index to use to determine location of the record, use surrogate key to allow Okay, even separate in the storage area. So I hope you know what's a surrogate key. A surrogate key. Last week I tell you the artificial column we create to represent something. For example, like me, my number is 2615, staff number. Nobody have this word don't have such called staff number one. Why you want to use number to represent yourself? Like you go to jail like that. Alright? No good, right? You got one number there. Oh, this number hang on. So that's why they purposely create to represent something. Like your item also. Okay, the reason behind it is NIMA can be duplicated. It's our student name. Sometimes I can tell you, my project student goes, wow, why you got 5 students with the same name? Then I must see which year they enter from the email. Then this one is my current student. So many names, certain names very famous one, you know. Okay, well, I tell you, Beng Seng, very famous. So many are behind, Yeah? Okay, so remember, so name, so remember the day I told you the normalizations? If they not provide the code, next choice what? If they didn't provide the code, email, name is last. Code, email also don't have, then you choose name. If not, choose the code. Okay, code have, you choose code. Don't have, missing, then you go second choice, email. Email also don't have because email is unique. Okay, then don't have, then name. Okay, but better we create the surrogate key. Okay, so we present the item. So DMS may have limit on number of indexes per table and number of bytes per index of field. That's why I told you already. Don't put so many index in the single table. Let they can limit the tree. Do more than that. Okay, remember? Be careful of indexes attribute with null value. Null value one don't put also. If your field can be empty one, don't put index. Okay, don't put like okay. So because certain only certain DBMS software not recognized now, but Oracle recognize. Okay, so this is one thing. Okay, something like this. 9 rules. This is a theory. Read out any 5 rules. 5 marks of course. In one of the past 5 marks. At least any 5 rules of using index. Okay, theory question. But then after that, there will another type of question is like this. This is one of the past here. On what attribute should index be defined to speed up this query? Give reason for each attribute selected. So, any idea? Primary key must be so student ID from student table. And then student ID, course ID from the registration table. Because these two also is primary key. So 2 already. Then 3, everything in the where GPA 3 already everything in group by and having group by and order by So order by student name. Yes, name also 4 already. Okay, so I think it's all like this. Okay, see the answer. Student ID in student tables. Okay, because the primary index. Okay, and foreign key that one. There's also student ID in the student, and this student ID in the student and in the registration issues when it's where clause join student and registration table. Means the student ID in the foreign key there. The next thing is okay registration. Then after GPA then student name then after that student ID and course ID in the registration table. So this one is a primary key. This one is a primary key, and this one is a foreign key in other table. This is answer. How you write? Yeah, so answer I already show you already how to do. Okay. So now we go to index. Okay. So index key is have a key and a value the ID and search. Okay. Normally the index record is every record for the first page if you use primary index. Okay. Second index is foreign key one. Normally second index is no, cannot say that. Second index is other than primary key. Second index is other than primary key. So for example, you create an index for the customer name. They also consider as a second index. Yeah? Second index That means it's not the primary so secondary Simple Okay. So this is a sample. You can see here. Key is AZ AZ in the page 2. H in the page 1. Something like that. FL in the this number. Something like that. Okay. So this is index. So you can refer this. Of course, all the index file is in order. the index file, it must arrange in order A to Z or 1 to 10. Index file always like that, but data file not necessary. Okay, your data file not necessary in the sequence. In the, they mean from the less value to the biggest value, not necessary sometimes. Okay, therefore only the index file you need to rearrange everything and refer to which page they directly refer. Okay, so you can cut short the time you search. If not, if the record in here, you need to search from top until bottom very long. You see? But you go to here, you only search 1, 2, 3, 4, 5, 6, 7, 8. Number 8, get the answer. Okay, add record. Oh, point here, get the record. Okay, if not, this one need to travel one by one until the end. 14,000. Okay, so remember, so this is a regarding index. Okay, so the index this is in the way also lah. It's a sample where state equal to FL. So that's why they put FL as an index one. Okay, index. Yeah, so you can see here, require a total of 10 IO access, 5 access to the index and 5 access to the data. Estimate. If not, you want to search from starting until the end, you need 14,776. So index file help minimize the searching line to get the data faster. Okay, so remember this. Okay, if the index is so important, why not index every column in the every table? That's why they say no parameter. Okay, so DMS2 are much in terms of index maintenance processing, especially how many attributes, how many rows, okay, and all require many insert, update, or delete. Okay, so affect the index. So especially the insert and delete operations. Update still okay, they refer change. Okay, so they call processing overhead. Okay, so we have common structures used. Hash index, next chapter will cover more detail. Hash index using the formula to calculate the index file. The one next chapter I show you sample and how to do step by step. B3 also same thing. Next chapter, chapter 7. Okay, the B3 got many. We focus on B past 3. B past 3. Next chapter, B past 3 and hashing I will teach you together. Chapter 7. Very important, This come up. B past 3 is very famous question in the midterm. Final exam. Final exam. B past 3. Okay, I'll tell you later on the coming chapter. After that, we got Big Mac index. Okay, Big Mac index, Big Mac index. So Big Mac index, I hope that you know what's a Big Mac index, like this, 1, 0, 1, 0, like that one. Okay, Big Mac index only suitable for those have different value, less different value. For example, sex, either male or female only, They don't have any other line. They don't have other. So either 0 represent male, 1 represent female. So only few. Then you can do this Big Mac to differentiate. Okay, but all this technique we use in the data warehouse for do analysis. Okay, so this is things happen. Okay, so this is a hash index. It's a formula. Okay, after calculate. Okay, hash function means formula lah. So calculate formula. Then they get they will assign to different bucket. Okay, so the example I'm using for next chapter is dy. Modulus. You know what's a modulus? The easiest formula is a modulus. The remaining of the dy. Okay, the dy, the remaining 0 are in the first bucket. The remaining is 1, then in the first bucket. So they got 8 bucket. Depends how big you want. Okay, later I will teach you what is that. Okay, simple. As a function is a limit formula. Okay, so after that we have full text database systems. Okay, so index on the text, content, and so on. Okay, so index structure of text, where system must support efficient information of the colon, this query, true, false, and so on, whether it's got or not. Okay, so then we go through your samples. Okay, this one is talking about the two focus on these two. Just now I told you one inverted index, whereby mostly used for the search engine. And one more is called signature file. Signature file. Signature file is the header of every file. Okay, your data is here. Before the whole file, the data is in the middle. Then you got header and footer. Footer means the end, checking, whatever. And the front also got header, the file header. So your virus, you know, you download this virus. They also ask you to update the virus definition, right? Can see not virus definition? The one actually is a file structure. Update the file structure. Okay, the first 2 bit is the extension of the file, like exe whatever. The first 2 bit, 2 byte, 2 byte. That's called 2 byte. Word file. Then behind got 18 bytes, certain data. Okay, people from this 20 byte, then the antivirus will search this 20 byte, any hidden information in there. Then they can suspect this one maybe is a virus file. This is how they do. Okay. That is all. Web search can cover at least 1 million documents. So web search engine can serve 100 and 1,000 queries per second. Okay. So that's why use an index to increase the speed of efficiency of search of documents. So this time, most of the time we're using inverted index. Okay. The more people search one, we put at the top. Okay. So this is how they do it. Okay. So in the index, effective for a very large collection of documents, use a most search engine. Signature file usually not used for the last database, but used for the antivirus most of the time. Okay, because only header of each file. Then after that, it got suffix tree and suffix array. Okay, so this one all like new term for you. Don't worry. You want it there, signature, suffix tree, array. I got movie. Okay, video play for you. Okay, don't worry. Okay, so there we go. Last. Okay, inverted index. You can see they based on the vocabulary and how many times they appear occurrence. Okay, occurrence. The vocabulary is a set of the different words in the text. For each word, the index store the document ID and the occurrence in the which the word appear, how many times. Okay. A query with the conjunction of the several terms, you read by the receiver the inverted list of the query terms at one time inserting them. Okay, so this is like that. Which word and how many times they appear. When then people accept one, then they put it top. Okay, so this thing So they finish all these chapters. So I play some video for you to more understanding all these indexes. So we start from the inverted index. Okay, let's enjoy the video. Now we can rest. Okay, sometimes lecture play some video.
Hello everyone.
Not loud.
So the question one is, what is inverted index? Why do we call it inverted index? And why do we need it? So, an inverted index is a consists of a list of all unique words that appear in any document, and for each word a list of the document in which it appears. The difference between index and inverted index, we can say, like for example, let's take the example of your mobile phone, your contact number, your mobile phone. The list of your contact is the index in your phone in which you have your home, work, friend, contact number. But if you dial the number manually, like for example 006018282242 and press call, and the name appears, it's an inverted index. They are both indexes. It is just the question in which direction you are going. Forward is from name to the number, and inverse is from the number to the name. And why do we need it? We need because we use inverted index to find out the word location in document or documents more faster. Example, think about the limit of CPU memory. Other indexes are not able to do the job well. Okay, so for the question 2, create document, count and position inverted index. So for this question, I have here my 3 documents. So in the document 1, I have the bright blue butterfly hanging on the breeze. In document 2, I have this to forget.
Okay, and here you must understand what I mean by stop word. Stop words means the word without any meaning one. So normally we do the analysis, especially the unstructured data. All these words we will minus out first. No meaning one. And, around, all this I will take out. before we do filtering lah, filtering. Then after remain what word, and then we just do the index, something like that. So stop word when you understand that concept.
The greatest guide inspired from everywhere. And documentary, I have under blue sky and bright sunlight, one not search around. So these are the documents, sentences inside the document. So for this, I need the first step to do the stop word list. There are some words that are not necessarily in our inverted index. For example, the word a, then, around, every, for, from, and other words. So once I did the stop words, the second step is that I'm going to find out which word is used in which document. For example, the first word here, the word this. The word this used in document number 2. So here is the document number 2, here is the word this. The second word is the blue, and it is used in document 1 to 3. So if we see here the word blue is in document 1, same time the word blue is in document 3. So that's how it works. Question number 3. What sort of data structure inverted index is given? Why? So the inverted index data structure is a central component of classical search engine indexing algorithm. A goal of search engine implementation is to manage the speed of the query. So the reason that they are using this data structure inverted index is just to provide the speed of the query. Question number 4. Give details on how web search engines use inverted index. An inverted index is a structure used by search engines and database to make search terms, file, or document. There are two versions of inverted index. The first one is a record level index, and the second one is a fully inverted index. A record level index, which tells you which documents contain the term, and the second one is fully inverted index, which tells you both the documents the term is contained and where in the file. Thank you so much for watching this video.
Okay, so in this video, what you learn is they focus on keyword and same time how many person click this keyword on this file. This is how the search engine arrange the file. Okay, so now we go for the next one. I think the voice very low. One volume. No speaker. This speaker can put anywhere. Where is the speaker? Anywhere, you know or not? Any student know the monitor got speaker one? Anyone know? Because I can open the cupboard. Okay, so go to the next one. Signature file.
Hello friends. In this lecture we will study what are signature files in information retrieval. You will be given a text document having large text which is represented by capital T. First step is to create the index for this text T. And signature file is the index which will be created for this text T in this video. Now, if anyone wants to search any pattern P in this large text T, then it will first look for the pattern in the index, that is in the signature file. If the pattern P is there in the text T, then the signature file returns the block of text where the pattern P may be available. So instead of searching in the whole text, we will search in the block of text provided by the signature file or the signature index. From this, you might have got some idea that while creating the signature file, the whole text will be divided into blocks. Though the time complexity of searching in signature file is linear time, but the constant factor is very small. So for not very large text, we can use this signature file as an index. Otherwise, we have another better option, that is the inverted index. Now let us take an example. For simplicity, let us take small text t, which is the statement. This is a text. A text has many words. Words are made from letters. First step is to divide the text into blocks of b words, small b words each. Next step is to underline the important words other than the stop words. Don't underline the stop words. The stop words in this text are this, is, a, has, are, from, etc. These words are not important and cannot represent the block, so don't underline these words. These are called stop words. Next step is to calculate hash values for all the words which are underlined using some hash function. We are not going into details of which hash function or signature we are going to use to generate these hash values. These hash values are also called bit mask. Don't worry about these hash values. This will be provided to you in the question. This will be given to you. Now next step is to calculate the hash values for each block. Once we have the hash values for each word which are underlined in these blocks, next step is to calculate the hash value for each block, which can be calculated by bitwise ORing the hash values of all the words in the block. All the words which are underlined in the block. For example, hash value of block 2 can be calculated by applying the OR operation between the hash values of text and the hash value of many. Similarly, hash value of block 1 will be equal to the hash value of string text, because there is only one word underlined in the block 1, that is the string text. Now to calculate the hash value of block 3, apply the OR operation between the hash value of words and the hash value of words, which will be equal to 100, 100, which is again equal to the hash value of words. Next, to calculate the hash value of block 4, apply the OR operation between the hash value of made and hash value of letters, which will be equal to 101101. After calculating the hash values for each block, next step is to create the signature file or signature index, which is a data structure in which we store the hash value of block followed by the address of that block. For example, this is the hash value of block 1 followed by the address of block 1. Then we store the hash value or bit mask of block 2 followed by address of block 2. Then we store the hash value or bit mask of block 3 followed by address of block 3. And similarly for block 4. Till now we have completed the steps to create the signature file. Now next we will see, if we are given a pattern P to search in the text T, then how the searching process will take place. Let us take an example. Let we want to search the pattern made in the text. First step is to find the hash value of pattern made, which will be given in the question. Next step is to take the bitwise AND of hash value of made with all the blocks hash value one by one. That is hash value of block 1 and with hash value of made. Next hash value of block 3 and hash value of made, and so on. Next we will check which one of the following values is equal to the hash value of made. This value is not equal to hash value of made. Now 0, 000, 100 is again not equal to hash value of made. Next also not equal to hash value of made. The fourth value, that is 001100, is equal to hash value of made. So there is a chance that made pattern might be available in the block 4. Next step is to jump to the address of the block 4 and start searching in block 4. So immediately we can find that yes, made pattern made is available in block 4. But sometimes it happens that the pattern might not be available in the block. In that situation, we will say that it is a false drop. In this example, it was not a false drop, but if the pattern is not found in the block, then we will say that it is a false drop. So that's all in this video. Thank you for watching.
Okay, so understand enough lah. I don't need to ask you to remember. Just understand the concept is like that. Break the file, then put the block and so on. Okay, so this is calling as natural file. So various definition is such by this method. Then go to the next one. They got two. One is a suffix array and one suffix tree. Okay, you go one by one.
An interesting topic I want to talk about today is the suffix array. This is an incredibly powerful data structure to have in your toolbox when you're doing some string processing. Suffix arrays are a relatively new data structure appearing around the early 90s due to the heavy memory consumption needs of suffix trees. Let's start with the basics and talk about just what a suffix is. For our purposes, a suffix is a non-empty substring at the end of a string. For example, if we ask ourselves what all the possible suffixes of the string horse are, we are able to come up with 5 unique suffixes. And they are E, SE, RSE, and so on. Now we can answer the question, what is a suffix array? The answer is a suffix array is the array containing all the sorted suffixes of a string. Let's see an example of this. Suppose you want to find the suffix array for the word camel. On the left, I constructed a table with all the suffixes of camel and the indices of where that particular suffix started in the string camel. Then, on the right-hand side, I sorted all the suffixes in lexicographic order in a table. The actual suffix array is the array of sorted indices highlighted in orange. We do not need to actually store the suffixes themselves if we know where the suffix begins in the original string. This is an ingenious idea, and it provides us with a compressed representation of the sorted suffixes without actually needing to physically store the suffixes themselves. All we need is the original string and the array of associated indices. In summary, a suffix array is an array of indices which store the sorted suffixes of a string. Furthermore, for a bit of history on the suffix array, it is a data structure originally designed to be a space-efficient alternative to a suffix tree, which in turn is itself meant to be a compressed version of another data structure called a trie. As a side note, even though the suffix array is very different from the suffix tree, suffix arrays can do just about virtually anything the suffix tree can, with some additional auxiliary information such as a longest common prefix array, which will be the topic of our next video. So thank you for watching, and stay tuned for the next video where I will introduce the longest common prefix.
Okay, so I hope that you know what is a suffix index array based on 1 word, 2 word, 3 word like that lah. Okay, so this is the idea. Then we go another one is a
Hi guys,
suffix.
in this video we are going to learn everything about suffix trees. So in the previous videos of this advanced data structures playlist, we saw what are tries and we learned different things about tries. And then because of the high space complexity, we moved towards compressed tries, right? And I explained in the introductory video of tries that in case of pattern matching, when we use tries, it
Have you learned the what decision tree? You know, you learn the decision tree?
reduces the time complexity from the order of length of the text to the order of length of the pattern, right? As the size of the text is very very large. So doing this reduces the time complexity to a large extent. So in case of pattern matching, we have got the text and the pattern. But what if the text that we are dealing with is not a collection of words? Rather, it is a series of letters like this. And there are no separate words in the text. So this is our text. And as you can see, there is a continuous series of letters, right? So in the common scenario, what we did was, we made a try out of all the words, right? But here, as you can see, in this text document, there are no separate words. There is no spaces between words. There is just a single word, and that word is actually starting from the starting of the document, and it is actually ending at the end of the document somewhere over here. So in this case, how do we make a try out of this document? So that is when we need suffix trees, right? Suffix trees is actually useful in such kind of situations where your text document is not a collection of words, but it is a continuous string of letters, right? There are no delimiters between the words. So the next question is, what is suffix tree? Let us see. So what is a suffix tree? A suffix tree is actually a compressed try for all the suffixes of the text. I've already explained what is a compressed try in the previous video. I'll provide the link to that video in the side button. You can go and watch it there. So a suffix tree is a compressed try. So we know what is a compressed try, but in that compressed try, what are the words we are inserting? We might have some words in the text that we are inserting in case of a compressed try, but because in this case the text document is like this, so we might not be inserting words. So rather than inserting words, we are actually inserting the suffixes of the text. For example, if this is the text that you have, right? Here also you can see that in the entire text there is only one word, or the text is actually a series of continuous letters, right? Here I have taken a smaller example so that it is easier for you to understand, right? Otherwise the text documents are even larger than this example over here, right? So if I want to make a suffix tree for this text document ACGACT, first of all I need to find out the suffixes of this text. Okay, so what are the suffixes of this text? Let us write them down. One suffix will be the entire word ACGACT, right? And the other suffix will be CGACT, starting from second position, CGACT. The third suffix will start from G, so it will be GACT. I hope you already know what are suffixes or how to find out the suffix for any given text. So another suffix will be ACT, and then we will have CT, and then this last suffix will be T, right? So these are my 1, 2, 3, 4, 5, 6 suffixes that I have for this text, right? So in this case, I'll have many suffixes, right? But here I am having a small number of suffixes because the size of the text is smaller. Very simple. So now, how do we draw a suffix tree for this text? So in the first step, I have found out all the suffixes. So in the second step, I'll do the same thing what I used to do in case of a compressed try. So in case of a compressed try, I was given a collection of words and I used to insert all those words in my try, right? So here also I am having a collection of words. And what are these words? These words are actually the suffixes of this text, of the text document, right? So I need to insert them into my suffix tree, which is also actually a compressed try, right? So let us insert these words. So we are basically going to insert all these words or the suffixes one by one into our compressed try. First of all, I'll be drawing a standard try by inserting all these suffixes one by one for a better understanding, and then I'll convert that standard try into a compressed try, and finally I'll get my suffix tree, because a suffix tree is actually a compressed try out of all the suffixes of the text, right? So now we are making a standard try. There is always a root node in the standard try, and let us insert this first suffix ACGACT. A C G A C T, right? So we have already learned how to do insertion in a trie in the introductory video of tries. I'll provide the link to that video in the side button, right? The next one is CGACT. So root doesn't have a child C, so we will make a child C, then CGACT, right? The next one is GACT, right? So we'll start from the root, GACT. Next is ACT. So we'll start from the root. Does root has a child A? Yes, it does. Does A has a child C? Yes, it does. Does C have a child T? No, C has only one child G. So we will make its one child as T, right? And then the next suffix is CT. So we will start from the root. Does root has a child C? Yes, it does. Then the next one is T. Does C has a child T? No, it doesn't. So we will make a child over here, T. Here I have made another child T for C, okay? So we have also inserted CT. Now the last suffix is T. So we will insert T over here, okay? So here I have made a trie out of all the suffixes of my text, right? But this is still not a suffix tree. Why? Because the suffix tree is a compressed trie, right? And as you can see, this is not a compressed trie. Why? Because in case of a compressed trie, every node should have at least 2 children. But here many nodes are having just one child, like this node, this one, right? So now let us convert the standard trie to a compressed trie for us to get a suffix tree, right? For making a compressed trie, what we do, very simple. Wherever we find a node with just one child, we collapse that child into the parent. Like here, C is actually a node having just one child T. So what we do is that we collapse this child T to C, and finally this T will be vanished and we will get a single node C T, right? And this will also be vanished, right? So the child has collapsed to the parent, or it has been concatenated to the parent, and this is what we do in case of every node which is having just one child. Again, as you can see over here, A has just one child, CT. So this CT will collapse to A. I've already taught this in the previous video, what is a compressed trie and how to form a compressed trie. So let us make a compressed trie. So this T will collapse to C, and here we will get CT, right? Here we will get CT, okay? And after that, again A has just one child CT. So CT will collapse to A, and here instead of A, it will also be concatenated with its child, which is CT. So here we will get ACT, right? Here we will get ACT, and the child is gone, okay? Again, G is having just one child, ACT. So ACT will concatenate to G, or it will collapse to the parent G. So this G will become GACT, and this ACT is gone. Okay, now the same thing we cannot do in case of C, because C is having 2 children. So the children will not collapse to the parent because C has 2 children, right? But here you can see A is having just one child C. So this C will collapse to the parent A, right? So this C will be concatenated to A over here, right? And both the children of C will be now the children of AC, right? Both of them will be the children of AC. Now, so again here you can see that T over here is actually the single child, or C is having just one child. So T will collapse to C, and here we will get CT, right? I'm just converting a standard trie to a compressed trie. I'm not doing anything else. Then this CT will collapse to A, and here we will get ACT, right? ACT, okay? Again, this G over here is having just one child, ACT. So this child ACT will collapse to G, or it will be concatenated to G, and on the over here in place of G there will be GACT, right? So here we will draw GACT, and there was a T here as well. But now C has 2 children. So these children will not collapse to the parent, or they will not be concatenated to the parent, because in a compressed trie you should have at least 2 children. that also implies you can have 2 children, right? So here also T will collapse to C, so we will get CT, okay? And here CT will also collapse to A, so here we are going to get ACT. But again, G has just one child. This G over here is having just one child, ACT. So this child will collapse to the parent, and here in place of G we will have GACT. So now if you look at this trie, you will see that each and every node is having at least 2 children, right? Except the leaf nodes, of course. I'm talking about all those nodes which are not leaf nodes. They will be having at least 2 children. So that means this is my compressed trie. And any compressed trie that is made out of all the suffixes of the text document is actually known as a suffix tree. So this is also my suffix tree, right? Because I have actually inserted all the suffixes of the text in this trie. Because in my text, I was not given words. Rather, I had a series of letters and there was no delimiters between the words. So that is why I made a compressed trie out of all the suffixes of that text, and when I inserted them into a trie, and when I converted that trie to a compressed trie, I got my suffix tree, right? So this is a suffix tree. And when is it useful? It is useful in such a case where you have not got a collection of words, rather you have got a series of letters. In that case, suffix tree is useful. Because what you do? You find out all the suffixes of that text, which is just a series of letters but not a collection of words. So that was all about suffix trees. In the next video, we are going to start another interesting advanced data structure. I'll be uploading many such videos on different advanced data structures in the upcoming videos. I'll be uploading many videos on different advanced data structures in the upcoming days.
Okay, thank you. Okay, so you know suffix tree, the index is like just how you make the word camel, CA, CME, whatever. The tree, you draw something like that. Okay, so just know as an idea lah, huh? So how we use it in practical, no need lah. So you just know that what is these two, huh? Any question? We have finished today's syllabus. Can do revision ah?
Yes.
What you want to ask regarding chapter 1 to 5 before we go for next week exam? Then we got another revision section on the next Tuesday night, 6 to 8. You get ready the question ah? You ask during the online class. Okay, now ask still got one more 40 minutes. Anything want to ask? Chapter 1. Chapter 1, how?
Sir, got any theory need focus on?
Chapter 1. Same as do revision, you show me ERD. Okay, never mind. So anyone want to show me today also okay lah. Any question then now you do know have idea, anything idea to ask? We ask on the last Tuesday. Okay, anyone have an ERD problem then ask now lah better. Okay?
现在你 OK 吗？
我算 OK 了。
如果你
我们的压力 OK 了，100%OK 了哦，check 了 OK 啊。那就这个8、6之间我 tabulate 出来，你先分配谁 tabulate 哪一个 tabulate 哪一个。你要分配好好，不要只是分的而已。
我就讲 tablet 是 create data。
是要做直接做 data insert data 那个。
就是要 insert data，但是你要分配好哦。你要跟着 parent child relationship 来分配啊，不然的话，等下有的人要等到另外一个人。